In the last two videos, we went over solving quadratic equations by factoring. Now we're going to solve by the quadratic formula. What's nice about the quadratic formula is it will solve any type of quadratic equation, whether it is factorable or not, whether it has rational or irrational answers, whether it has complex or imaginary solutions. These will solve every different type of quadratic quadratic equation. Now, your formula isn't exactly, pretty. It's a big one, but it's really not that bad to use once you start using it a couple times. In the past, you would have to memorize this. You're either taking this class online and you're getting to use your notes, or you're taking it on campus and you get a note card and you can write that equation on your note card. So either way, you really don't have to memorize it, but I still like showing this anyways. Here is the quadratic formula to the song Pop Goes the Weasel.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
You want to sing it all together? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I could literally make that my ringtone, but for the sake of time, we won't keep listening to it. That's the way I learned how to memorize it, was to Pop Goes the Weasel. I also was looking in here, and there's one right here for Bad Romance by Lady Gaga. That might be worth your time. It was kind of funny. And then this one was really funny too. I'm not gonna do that one, but this one was really funny too, if you want to listen to that, by two different songs. But either way, you really don't have to memorize it, so you don't really have to, worry about that too much. So anyways, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It looks like a huge formula. It is really, really simple. We're going to substitute in and we're going to simplify it. So here, example 2, use the quadratic formula to find the real or complex solutions. Next video, we're going to go over our two complex solutions. Complex solutions have our I in them, have the imaginary component. So if this is my quadratic here, and I was trying to solve this by factoring, we would have, what would we have? Okay, so we have, it's already in standard form, it equals 0. It has no GCF, so we would go into our x. So we would do a times c is 1 times 2. My b term is -4. So what adds up to -4 but multiplies to 2? And there's nothing here, right? And so when there is nothing here, this is when we have to use quadratic formula. And when we're lucky, we have the quadratic formula to still give us our solutions. So the first thing I'm going to do is label my A, B, or C. So A here equals 1, B is -4, and C is 2. So now I'm going to substitute in my values into my A, B, and C into this formula here. So I have x equals -b. So negative a -4 is 4, plus or minus. Here's where some students can make a mistake. When your b is negative, you have to make sure you substitute that in parentheses. When you do -4, not in parentheses, that equals -16, because all that's getting squared is that 4, and then that negative tags along. But when you have -4 in parentheses, that's now -4 times -4, and that's going to give you a +16. So if you don't substitute that in with parentheses, you're going to get the wrong answer. So be careful with that. Okay, so that's my b squared minus 4 times a, which is 1, times c, which is 2, all over 2a. So 2 times 1. So substitute it in, and now just evaluate things. We're going to have 4 plus or minus. We're going to figure out what goes under my radical. 2 times 1 is 2. So let's put everything that's under that radical in our calculator. So we have parentheses, -4 squared minus 4 times 1 times 2, and we get 8. Now, my math lab is going to want you to simplify your square roots. Now, there's an optional assignment in your My Math lab to help you practice simplifying radicals if you want some extra practice. But I'm going to come over here to the side. So when I have the square root of 8, we need to break this down technically to prime numbers, but technically you don't have to. But here we have 4 times 2. 2 can't get broken down anymore, but 4 is 2 times 2. You want to find pairs of numbers. So here I have 1 pair of 2s. This 2 will come out. And then what does not have a pair stays in. When I taught in high school, I talked about dates. Whatever has a pair gets to leave the house on a date. Whatever doesn't have a date is lonely. He stays inside. Okay. So now this is 4 plus or minus my 2 square root 2 all over 2. And for the record, you can check these as well. If you put in the square root of 8, you can see what that decimal equivalent is. Then put in your simplified radical, and you should get the exact same numbers. So we're not changing anything. We're just writing it basically how my math lab wants us to write it. Okay, and now we can simplify even further. When I'm simplifying, I'm wanting to look at 3 numbers. I want to look at what's in front of the plus or minus, what's below the plus or minus, and what's at the bottom. If those are all divisible by the same thing, we can simplify it. In this case, 4, 2, and 2 are all divisible by 2. So if I divide everything by 2, we get 2 plus or minus 1 square root 2 all over 1. This is a fine answer. We really don't need either of these ones. So my actual final answer is 2 plus or minus the square root of 2. Now, I do want to check this in the graph, but before we do, I do want to make note of something here. Notice that the square root has a 2 in it, and that did not get circled and it did not get divided by 2, right? This stayed square root 2, square root 2, square root 2. What is outside of radicals, meaning this 4, 2, and 2, does not mingle with what's inside radicals, this 2 here. So please, 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 you're only simplifying what's in front of the plus or minus, what's behind the plus or minus, and what's down here below that you're dividing by. So even if this was a 3, we could still simplify because we're not paying attention to what's under that radical after we've simplified it. Now, we have still a quadratic, an x squared, meaning I have 2 answers. This represents both of my 2 answers. My 2 answers are 2 plus the square root of 2 and 2 minus the square root of 2. Notice I changed what's in front of or what's behind that plus or minus. This 2 stays positive in both of my answers. So now when I graph this, I'm doing x squared plus 4x plus 2 and graphing. And that's the one solution. Let's go back to Zoom 6. So Zoom 6 gets me to that standard. Okay, there's my two solutions. I'm going to trace. So I have 2 plus the square root of 2, and I have a y of 0. And you can also see what that decimal equivalent is, but here I'm looking for, yeah, the y 0, so that's an x-intercept, and 2 minus the square root of 2, and we have another y equals 0. So those are both correct answers. Okay, let's try again. What should I do first on part B here? Okay, just like with factoring, the first thing we're always going to do is put these into standard form. So I need to subtract that 2 over. So I have x squared plus 8x minus 2 equals 0. So now using this, my a is 1, my b is 8, and my c is now negative 2. It is not 2. So let's use our quadratic formula. X equals negative b. My b is positive, so this will become negative 8 plus or minus the square root b squared. Now, when your b is positive, it really doesn't matter if you put this in parentheses. 8 squared is 64. 8 in parentheses squared is also 64. Does not matter whatsoever. It matters 100% when b is negative. But just for good practice, let's just always put it in parentheses, and then we don't really have to remember when do we do it and when do we not do it. Let's just do it every time, and we don't have to remember when to do it or not. Minus 4 times a, which is 1, times c, which is negative 2, all over 2a, which is 2 times 1. So clean this up. I have negative 8 plus or minus. We'll figure out what goes under that square root, and 2 times 1 is 2. So let's put this in our calculator. And we get 72. So let's simplify this. The square root of 72. And you can break this down any way you want. If I go 8 and 9, 8 we just did over here is 4 and 2, which is 2 and 2. 9 is 3 times 3. I need a pair of something to come out. So I have a pair of 2's and a pair of 3's. Those are going to get multiplied together on the outside. And then what does not simplify or does not have a pair, this 2 here stays inside. So we have x equals negative 8 plus or minus 2 times 3 gives me 6 square root 2 all over 2. Now, can I simplify this even further? And what I'm looking for is the number in front of the plus or minus, the number behind the plus or minus, and the number that we're dividing by. And all of those are divisible by 2. So negative 8 divided by 2 is negative 4. Plus or minus 6 divided by 2 is 3. Does this become the square root of 1? No, no, no. What's inside radicals does not mingle with the outside. It did not get circled. It does not change once it gets simplified. So it's going to stay square root 2. And then I can put that all over 1, but not really necessary, right? So here is my answer. Let's check this. Putting that in my calculator. I'm going to graph it. And let's check our two answers. This is, we'll hit trace. This is -4 plus 3 square root 2. We get a y of 0. And this is also -4 minus 3 square root 2. Now we've went over this in a previous video. When you get something like this is scientific notation. And so when you have e to the negative whatever number, that's basically 0. So both of those are correct.